I just nailed myself. Okay, this pipe, there'd be a pulley up here, cable down to the float inside, cable comes around through this hole. There's a couple of pieces of metal that form a guide that the marker slides in and up and down in. The piping here is for the steam line that goes into a coil heater in the tender tank. These two are devices that help control the brakes on the tender. Behind the cab, you have an emergency brake valve. This long box over the doorway holds your flags, fuses, which are also flares, and what are known as torpedoes. These two brackets on either side of the doorway held a 2x4 and some canvas that they could roll down over the door opening in the wintertime to help keep it a little bit warmer inside. Now, as I said earlier, watch your step and look where you're going. I showed you why. I stand 6'2", and this doorway on me comes up to about my nose, and I didn't duck far enough earlier. The portion of the boiler that extends back into the cab is known as the back head. Looking at the top of the back head from the fireman's side, this valve here is known as the fountain or turret valve. This valve controls all the steam that's admitted to the gauges and valves inside the cab. Other valves on the fireman's side, this first valve is your steam throttle to the injector. This valve goes to the Powell National E2 turbo generator. This valve emits steam to the oil burner manifold. The oil burner manifold consists of your blower valve. This valve down here admits air to the bell ringer assembly, bell ringer valve. This is your oil heater valve, blowback valve, atomizer valve, tank heater valves. This is your firing valve. The ring down here controls the damper. The device we're looking at is the damper. The dampers must be regulated to suit the conditions under which the locomotive is working. When the locomotive is standing or drifting, fire pan damper must be regulated to prevent excessive cold air being drawn into the firebox, to avoid possible damage to the firebox, sheets, and flues. When the locomotive is working, the damper should be regulated to get proper admission of air to the fire for proper combustion. The piping below the damper is the engine oil heater. The heater casing or chest is constructed of tubing of proper strength to sustain boiler pressure, having the ends closed by heads which are in the form of reducer sockets. In the outer ends, through bushings, is fitted the oil supply pipe, forming a portion of the conduit through which oil is fed from the supply tank to the burner. All steam and oil joints are made tight and piping securely fastened by screwing up the cap so that it abuts against outer end of bushing. Heater is placed between the oil feed cock and the burner. In the operation of engine oil heater, steam is admitted by opening the valve. Steam passes into the engine heater casing and around oil supply pipe, heating the oil and escaping through drain. The valve controlling the flow of steam to heater is the engine oil heater valve. This valve should be open sufficiently to allow a light flow of steam through the heater casing, as the opening of the heater valve to its full capacity accumulates high-pressure steam in the heater casing and results in gasifying the oil, causing intermittent flow to burner. This valve here controls the squirt hose. This pipe here is your water glass. This is a light. Now this little valve on top of the boiler is line that goes to your steam gauge, which would be located up on this plate. This here would be where your air gauge is. This is your steam gauge. Number 9 had an operating boiler pressure of 180 pounds per square inch. Now in a hydrostatic test, the pressure would have to be raised to 225 pounds per square inch in the boiler to make sure that the boiler was safe. This is a smaller brake gauge. Now the Westinghouse air gauge, the black hand is your main reservoir pressure and the red hand is your equalizing pressure. Now down below, this is the fire door, and the little metal plate is the peephole. Shot of the peephole. This is where the firemen would throw scoops of sand to sand the flues of the locomotive. Now over on the engineer's side of the back head, these 3 valves are water gauge cocks, or better known as tri-cocks. These work in conjunction with the water glass. This is the train brake. This operates the entire train. These 2 valves operate the left and right side of the sanders of the sand dome. Engineer side injector valves. This valve is the throttle. To open the throttle, you pull back on it, and to close, push forward. The device here is a Nathan Bullseye 9 hydrostatic lubricator. Of the lubricator, showing the front, top, and side views. You've got the condenser. This is the fill plug. These are hand oilers. This is the reducing plug. Delivery nut and tailpiece. This here is your water valve. This is a stud nut. Sight feed glasses and casing. Sight feed glasses and casing again. This is the feed nozzle. This is the main body. Got a gauge glass and casing. This is known as your waste or drain cock here. These are your regulating valves. This up here is your top connection to your steam. This is an equalizing pipe inside. Then you've got oil pipes. There's a water pipe here. Here's your oil pipe. There's your sight feed drain valves. There's 3 of them here. There's what's known as a reserve glass encasing. Then you've got a cleaning plug down here on each end. This is the body plug here. Then you've got an oil pipe plug underneath. This here is your gauge glass bracket. Back here is a gauge glass cap. Now on the Bullseye 9 lubricator, you'd put oil in the fill plug, that's what I'm pointing to, then you'd open your water valve. These are the feed cocks. The first one is to the air pump. You want about 2 drops a minute. Then you have the middle one is for the fireman side cylinder. You want 5 drops a minute. And the engineer cylinder, you want 5 drops a minute. Now to refill the lubricator, first you shut down your steam pressure, open the waste cock, allow the pressure in the water to escape, shut the waste cock, then you open the fill plug. Be sure that before you open the fill plug that you've shut your water off. Now, if you don't turn off the steam pressure before you open the fill plug, then you're going to have a hard time explaining to your shop foreman why you, your fireman, and the entire backhead and cab is so well lubricated. Because what happens is, if it's under pressure and you open up that fill plug, there's going to be oil all over the place. So anyway, open the fill plug, fill it with oil, close the fill plug, turn on your water valve, turn on your steam valve before the locomotive does any work. Remember that the feed cock on the far left, for the air pump, you want 2 drops of oil a minute. The center and right feed cocks are for the cylinder, the valves, and you want 5 drops of oil a minute. This large bar here is known as the Johnson bar. This is the lever for forward and reverse motion of the locomotive. Right now it's in the center or neutral position. To start a locomotive moving forward, you pull the handle and push it forward. This would allow volume of steam to enter the cylinders. Then once you get running, you can pull the Johnson bar back, what is known as cutting off. This admits less steam into the cylinder and uses the expansive power of the steam instead of the volume. To reverse the locomotive, be similar. You'd pull the Johnson bar back all the way for full stroke and cut off position. Now on the side here, pretty much been obliterated, there would be a line or a notch. This would be known as the company notch. This is the notch that the railroad company would want you to run in most of the time. It has what is known as Stephenson valve gear and link motion. This is the rod that comes off of the Johnson bar. As the bars move forward, pulls this rod back, pulls this arm back, raises this, and raises your links. And as that happens, it moves the valve rod in reverse, the opposite. Now this is your back driver, and these are what are known as eccentrics. And these are your eccentric rods. And as I say, forward motion, you'll raise the Lincoln blocks, and in reverse, they'll drop down. This will move the valves and be able to change the direction of your locomotive. On the engineer side of the back head, throttle valve for steam for the engineer side injector. This is the steam valve for the hydrostatic lubricator. And this one is for the air pump. On the floor of the cab on the engineer side are a couple of handles. This first one is the cylinder cock. Forward is in closed position. What they would do, before you start moving the locomotive, the engineer would open the cylinder cocks, and as steam is admitted to the pistons and the piston moves forward, it blows out any water or condensation that's in the cylinders until the train gets rolling. Then you can shut the cylinder cocks. If this isn't done, water does not compress, and what will happen is you wind up blowing off the cylinder head. This is what cylinder cocks, notice the steam each side of the ports as the pistons go. The valve here is for the blowdown valve. What they would do when you had boiler full of water under steam, there's sediment in the water, and it wants to settle down at the bottom of the firebox at a point which is known as the mud ring. What this valve does, it is opened for 5 to 7 seconds and then closed, and it, using the steam pressure, it blows the water out at the bottom of the boiler by the mud ring and blows out all the sediment. This is what blowdown looks like. You'll notice that the steam shoots out probably 20-30 feet from the train. This valve here is an independent train brake. Presently in the on position, you've got lap and release. Above the engineer's head is the handle for the whistle. Above the fireman's seat, this box is for the Pile National generators, controls, switches in the on position. Down below would be a lever. This controls the headlight and the backup light on the tender. Center is in off position. To turn the rear backup light on full, you put the lever in this position, rear dim here. Headlight full in this position, headlight dim this position. Directly above the fireman's seat, you'd have a boiler washing certificate here and a monthly or annual locomotive inspection report in this space here. And of course, also above the fireman's seat, this rope is for the bell. The bell is rung when the locomotive is started in forward or reverse, at grade crossings, and rung wherever a warning needs to be sounded. The atomizer. The atomizer is used to spray the oil into small particles by the use of a jet of steam so that it may be more easily vaporized and ignited, also to carry the oil against the flash wall with force sufficient to diverge particles in all directions to effect a condition that will completely fill the firebox with flame. When the atomized oil strikes the flash wall, the continued driving force assists in further separating it, which from the effect of the heat present quickly evolves into inflammable vapors that are thrown off in all directions to burn as they mix with the air being admitted. After closing throttle and cutting down the firing valve, cut down the atomizer correspondingly. Slight change in the adjustment of the atomizer sometimes produces good results when locomotive is not steaming well. That must be left to the judgment of MrHMYJIM. Bear in mind that the proper adjustment of the atomizer valve is to use the least amount of steam required to fill the firebox with flame. If this effect cannot be produced, determine if the burner is partially stopped up or out of alignment, or if there is some obstruction in the direct line of the oil flow, or if the flash wall is intact. Now, the blower. It is usually advisable to open the blower when the throttle has been shut off, but when blower is used, it should be worked as lightly as requirements will permit. When the locomotive is standing, if greater fire is desired, the blower may be partially opened to give a better draft. The use of the blower increases the draft through the firebox. The additional air bringing in a greater supply of oxygen, bringing the firebox temperature up as gradually as conditions will permit. This is inside the firebox of number 9. This down below is the burner. This is your back flue sheet, 200 flues. The sheet up on top is your crown sheet, and then you've got your side sheets. This is your brickwork. Back at this end of the fire pan is known as the flash wall. Now, the burner must be adjusted so that the atomized oil will strike the flash wall. The burning oil must pass across the firebox parallel with the side sheets and the floor of the firebox. It should strike the center of the flash wall. If it strikes to one side or the other, then only that side will be filled with flame, and that adversely affects the steaming of the locomotive. If the oil strikes some obstruction before reaching the flash wall, it may result in poor steaming of the locomotive and cause black smoke and carbon. The oil and steam ports at the mouth of the burner, see if I can get a better shot of it. Oil and steam ports at the mouth of the burner. Kind of difficult there. Okay, hang on a second. Oil and steam ports at the mouth of the burner must be kept open and openings should be uniform throughout their length. If open at one side more than the other, larger quantity of steam or oil will be drawn from that side. Upper and lower lips of the atomizer port must be even. If there's a slight extension of one beyond the other, it will direct the flame upward or downward. Burners should be carefully inspected and adjusted before the locomotive leaves the roundhouse in order to assure a pre-steaming locomotive and economical combustion of fuel. If for any cause the burner should get out of line or out of position while on the road, enginemen should adjust and report it upon arrival at the terminal. Now, if you look, the top of the crown sheet, there, and there, those are fusible plugs. What it is, there's a soft metal alloy in them. If the water should drop below the crown sheet, the metal will melt inside. Steam will come through and put out the fire. These are safety devices. Now what you've got next to it here, these rows are your crown and radial stay bolts that connect the firebox sheets with the outer boiler sheets. Now, how to blow out the burner and the oil pipes. To blow out the burner, first you close the tank on the oil valve, burner and oil pipes. First you close the tank oil valve on tender, then you'd open the blower valve to create a draft through the firebox. Then you open the firing valve gradually until full open, staying on the left side of the fire door. Once firing valve's full open, you'd open up the blowback valve. The steam then passes through the blowback valve into and through the oil feed pipe and oil opening of the burner, slowly blowing out any oil that remains in the feed pipe. When this is accomplished, you open wide the blowback valve for a few short seconds to allow the full steam pressure to blow through the oil passage of the burner. Then close the blowback valve, close the firing valve. Okay? And then, of course, close down the blower. Now, to blow back the oil feed pipe passage back into the oil tank, you'd open the tank valve, be sure that the firing valve is closed, you open the blowback valve. This allows the steam to blow back through the pipe into the oil tank, driving with it any obstructions that may be in the feed pipe or on the seat of the oil valve. Then you close the oil heater valve, close the oil tank valve, close the blowback valve. Now, except when you're blowing out the oil pipes or the burner, the blowback valve must be kept closed. If the blowback valve is left open, or if it's leaking, steam will pass into the oil pipe and into the oil, causing intermittent flame by the intermittent flow of the oil to the burner. And this would be accompanied by black smoke and possible explosions. Now, water may accumulate in the oil by the improper handling of the oil heater valve. When the locomotive is standing or drifting, this water will settle toward the outlet, get into the oil pipe, pass into the burner, and then it puts out the fire. Water in the oil also produces intermittent flashes, or what is known as kicking of the fire, And at times the fire will die down entirely and then flash up as the water disappears and oil reaches the burner. Water in the oil produces a very dangerous condition. It is very important that water should not be allowed to accumulate in the oil tank, as a spasmodic fire will result